Good morning, DefCamp. So happy to see so many of you this morning. I had such low expectations. Honestly, I mean, we all know what happens in the first night of a conference. That's literally when everything happens. So seeing so many of you so early, thank you. So, before I begin, yeah? And on that note, a subject that's very dear to me, and I apologize for being just a little bit off topic, but I feel that this is important, is mind the journalists, mind the news, and mind the way the journalists screw up the news. There's a million ways they do that. Sometimes they outright lie. However, there's many situations when you cannot do fact-checking and they present some information as being true, and it may be true, but taken out of context. And I'm just going to give you an example. 300 servers belonging to a security company, Bitdefender, were hacked in September. Show of hands who believes that this news is fake. Cool. What? Because honeypots. We have like thousands of honeypots. Honeypots are servers, right? So technically, a journalist can make the goddamn argument that this is effing true. So be mindful of how you read the news and how you're being presented the news, especially during this completely useless election period. I mean, the election is okay, but we all know what's going to happen. And also, fresh from last night, I'm very proud to say that we put out a new research paper about Ring doorbell. And it was instantly covered by almost everybody who is anybody, which was kind of cool. But this all happened last night. So yeah. And the paper is available on our website. You can read it. It's kind of cool, yeah. And I would like to emphasize the fact that the journalists loved it because it had the Amazon logo on it. I mean, I was talking to Luciano earlier. We've put up research much cooler than this about, hacking millions of devices and doing all kinds of crazy stuff with a real impact on the World Wide Web, and it received significantly less coverage than the Ring doorbell, which essentially the whole thing is that you can steal somebody's Wi-Fi password, right? If they have a Ring doorbell, which is cool, but it's not as cool as hacking millions of devices. However, this having the Amazon tag on it, TechCrunch, CNET, Gizmodo, everybody, it's like full-blown coverage. So, to the topic at hand. We have been doing IoT security research for the past 5-6 years. And as of like 3 years ago, we started to focus a lot on cloud implementations in IoT. We've published papers, we've sent notifications, and just as the first joke of the day, this is kind of what we imagine happened at Vendor HQ when we sent our notifications, because this is literally the kind of feeling that we got from their replies. No sound. Well, essentially the guy says, do you know the cloud? And she says, fuck! And the guy says, nobody understands the cloud. Yeah, it's because, again, apparently many people love the cloud. They love AWS and they love S3 and they love, I don't know, different types of cloud platforms, and they're pretty much okay. But when it comes to implementing them, not that much. So this is a slide that we have a lot of content. I have a lot of content in this talk, so I'm gonna apologize for skipping kind of through some of the things. Mostly theory on how to start with hardware hacking in the upcoming slides. You're going to have the slide deck available on the DefCamp website. So be warned that some of the information here, I'm just going to go through really, really quick so I can focus on what's hot and cool. So some of you have maybe seen this slide, this slide before. What if I told you that IoTs are like a WordPress website. Can anybody in the room raise their hand if they see the connection between an IoT and a WordPress website? We have one brave and intelligent sir here. Great. So before I give the answer to this puzzle, I'm presenting you with this stack. For those of you who are old enough, Red Hat 6.2, we have a stack hardware, Red Hat 6.2, and VuFTPD. Anybody here remember VuFTPD from like 25 years ago? It was known to provide remote root access to any Linux server reliably, right? You have hardware, a Windows platform, and IIS 5.0. There was the infamous IIS 4.0 and 5.0, which had like exploits. You could access the file system on those servers from, as an irony, Internet Explorer, because of some directory traversals and some other vulnerabilities. So you have this other stack, right? Hardware, operating system, and then IIS 5.0. Also, hardware, Windows, and RDP. Hardware, Windows, hardware actually in whatever, and Joomla. This is the stack of an IoT. It's hardware, BusyBox in 90% of the cases, and an application layer. So in the case of IoT, you have like hardware, operating system, and an application layer, much like the case of these other stacks. The addition for IoT is that you also have cloud and the mobile app, which essentially extends the attack surface when you want to do vulnerability research to these other components as well. So you'll have not only have the application layer here, maybe BusyBox is okay. Let's just, for the sake of argument, say that BusyBox is okay. The application layer is not always okay. The mobile app and the way it communicates is not always okay, and the cloud is definitely not always okay. I'm sorry, I mean, you're gonna see, actually. So essentially, IoTs are just websites. Anybody that contradicts me on this, they're just websites, they're web services, all of them. Even Roomba runs a web server. There was like, at some point a tweet about somebody saying, if I send a malformed package to my Roomba's HTTP endpoint, it crashes. And somebody made a joke saying, if only dogs had that intel. Dogs being afraid of vacuum cleaners and all that stuff. So yeah, IoTs are just websites running Linux, but with a significantly bigger attack surface. Now, this is the part where I'm going to just skim through. If you want to get into IoT hacking, look for open services. There's a lot of command injection. A special mention to buffer overflows. Who here is familiar with the compile flag PIE, P-I-E, position independent executable, right? PIE as a flag is used to allow the binary to be moved at different memory addresses in order to enable ASLR to function. So essentially, if you're able to get a buffer overflow in a binary, you're not able to get an RC and command execution in it because you're not going to know the memory address of the function that crashed. In IoT, there is no PIE. There is no PIE in IoT. Simply because no vendor enables PIE at compile time because it uses too much CPU cycles. So essentially, if you get a buffer overflow in an IoT, you have a reliable, in 99.9% of the cases, remote code execution, which is kind of cool. So it's worth remembering that. Also worth mentioning, there's a lot of shared code. At some point, we did a research on a device, and then we found the same vulnerability in like 12 other brands, different brands, because as it turns out, they were using the same core SDK for the firmware. Okay. Also worth mentioning that you can hijack the bootloader of IoTs. You hook up to the serial interface, you're going to be prompted with a login shell. Arguably, you're not going to know the credentials to log on. I mean, of course, they're going to be root and 1, 2, 3, 4 in many cases. But for the sake of argument and academic purposes, let's say that it's a bit more difficult than that. You're going to be able to hijack the bootloader much like you would do on a Linux machine. You just pause it. You just have to be very quick at pausing it. And then you just pass arguments to init, and then yeah, you're gonna be dropped into a shell, and exactly like you would do when you want to recover your root password on a Linux machine. So you can do this with IoT quite reliably. Like the majority of them, more than 60 or 70% of the IoTs that we've analyzed had a serial interface that we could find and do this. So then you get access to the file system, and you have an easier time doing vulnerability research with access to all the files on that IoT. Now, to the topic at hand. Traditional botnets in IoT, like Mirai in 2016, would iterate IP addresses, find an open service like Telnet, and then try combinations, like 85 combinations of usernames and passwords. Root 1234, root XCD, Gauri, blah, blah. Fast forward 1 or 2 years, they've added some web-based exploits for the Netgear routers, Netgear R7000, and one other model that had a command injection that said URL of the router /cgi.-bit/?, and then you would, if you add the semicolon to any command, the router will execute that command. So the botnets have added to that functionality as well. So this is how traditional IoT botnets operate. We're monitoring right now about 12 botnet families, summing up to about 300 botnets in total based on IoT. As a fun fact, they're mostly used for DDoS. And we've seen a direct correlation between the functionality exposed by the botnets. We infiltrate that, right? So we have honeypots, we get the binaries, and we pretend to be infected. So, and without executing their commands, we're receiving their commands, right? So attack that IP, denial of service that IP. And there's a direct correlation between the commands and the functions available in these botnets and the websites that you see that offer stressor services and footer services. The same functions, and there's this direct correlation between them. Anyway, trivia. So, this is what I would want you guys to pay a little bit of attention. Most IoTs have moved to the cloud. Why? Well, because it's more secure. You don't need to open up the IoT in the internet. You don't need to do port forwarding anymore. Everything is really by the cloud. There's no direct connection to the IoT, so the botnets will not work anymore. There's not going to be the option to iterate the IP address and see if there's any open ports. There's not going to be any open ports. So that's cool. And the way they've implemented that is this. First of all, they have a modular architecture. Most of the cloud platforms are provided to the IoT as a third-party component. I'm building my vacuum cleaner. I don't do cloud, so I'm buying the cloud platform from vendor X. Vendor X provides me with a binary, put that binary in my IoT, and everything works. I have this, instant system for cloud management for my IoT, which is kind of cool. The way it's designed in 99% of the implementations of all the cloud platforms is this. There's a device ID, which is randomized, it's 32-bit very often, it's completely unpredictable, and that's the authentication used when talking to the IoT. So essentially the mobile app will tell the cloud, I want to talk to that device ID, and if you know the device ID, you're going to be able to interact with it. Every now and then they also add a password, as we're going to see. So this is if you know that device ID in a vast majority of cloud implementations for IoT, then you're going to be able to interact with that device. They have a decent usage of encryption, so the entire communication between the device and the cloud, between the mobile app and the cloud is encrypted. And this is a very generic description, and I'm assuming that it applies to 90% of implementations for IoT. So that's it. However, not all cloud implementations are perfect. So, as I was saying, that device ID is the only authentication that's used. No, nothing else. And the big problem, as we're going to see, is that some vendors in the illustrious intelligence, they add stuff on top of that. So they receive the implementation from the cloud vendor and they believe that it's not enough, so they want to improve it themselves. And having no experience in how the cloud works and how the platform works, they screw it up. And we're going to talk about this in MPPT as well. So a few words on S3 buckets. many cases, S3 buckets work like this. I'm storing a file in this path. And then that path is generated by whatever device generates the file. So let's say I have a recording camera and I'm storing the recordings on an S3 bucket. I know the path and I'm relaying the information to the cloud, and that information is related to the mobile app that has to read the recording. You cannot go up one level, in theory, in an S3 bucket. So you get the path to your file, and if you know that path, then you can read that file. That's kind of how the security of S3 works. Again, the vast majority of implementations. And you shouldn't be allowed to see other files in that S3 bucket. Unfortunately, if you want to, again, look at common vulnerabilities in IoTs, a lot of implementations allow you to see S3 buckets. So we've seen an alarming number of vendors like the equivalent of recursively listing that vendor's S3 bucket, which implicitly means that you are able to list all the recordings of all the devices of all the customers belonging to that vendor, which is really screwed up because not only is it a huge privacy invasion, especially in the case of baby monitors and security cameras, a lot of this stuff is done without the user's knowledge. There's a lot of stuff that's being recorded and put into S3 buckets without the user's knowledge. With the S3 buckets unsecured, people can access those recordings and they can hear ambiental audio around the camera and all of these things, and it's kind of really, really screwed up. And we've seen a lot, unfortunately, of this happening. Now, MQTT is a new management system, well, not necessarily new. Essentially, the way it works is that the device registered to an MQTT controller, and it's also something like a tree architecture, a tree design. And, well, you register to /vendor/device ID/topic, where topic is, I'm online, I'm offline, I'm doing this, I'm doing that. And these topics are known by the mobile app. So the mobile app knows I can register to /vendor/device ID/online. So I can get notifications when the device is online, I can get notifications when the device is offline. Ideally, I wouldn't know other device IDs, so I wouldn't be able to read other people's statuses on MQTT. So, unfortunately, as we've seen in some implementations of MQTT, you can register to / and get the statuses and configs of all the devices using that MQTT platform. And with that information, you get people's email addresses, you get people's device status, a lot of useful information, and you also device ID. So in a hypothetical scenario, when you would want to target somebody and get their recordings, is that you would register to /vendors MQTT, get all the notifications from all the devices until you see that person's email address. With that email address, you would see their device ID, and with that device ID, you would go to the S3 bucket and list the recordings, uniquely the recordings. And of course, this is a purely hypothetical scenario. I don't know anybody that has done this. Of course. So, but I encourage you, if you're into this kind of research, to do it as well, because we're going to talk about some legal issues at some point in this talk towards the end. Yes. Now, some other things that we've done, the infamous, I've done presentations with this power outlet for about a year and a half at least 2,000 conferences. Was our first big presentation about how to hack, to get a root connect back shell on a power outlet on a device by exploiting the cloud. Essentially, they had a command injection vulnerability, and their authentication was the MAC address. So if you send a request to their cloud saying, tell this MAC address to turn off, then that's all, it would turn off. And then you would send a request to the cloud, tell this MAC address to update the password to this other password, and they would actually use the system command passwd, right? So you just semicolon whatever, set a password to semicolon whatever, and then yeah, bam, you get command execution, connect back shell, and there you go. So we get to the topic of today. This is actually I've built up for half an hour for this. So the Godzilla Smart Security Camera. The reason I'm doing this talk is that it's very, very explicit, and it really, really explains why cloud implementations are bad, and why vendor replies are bad, and sometimes why not picking the proper pen testing company when you're doing pen testing assessments is really, really bad. So a little bit of background. And at this point, cool. Nice. Just checking. So now, we did our initial analysis. Obviously, the first thing that you start with, you see how the app communicates with the device, and you see how the app communicates with the cloud. They have an API at apps.garzilla.com, and after the initial account registration, the app receives a 6-digit long user ID. Just out of curiosity, anybody sees a problem just in this slide? No? You already know it. Okay, moving on. That user ID cannot be changed, and it's incremented by 1 for each new account. And ours, if you want to have fun with it, is 408.311. And obviously, you're not allowed, but I've heard that at this point, it got up to about 590,000 user IDs. So, cool stuff. And more than that, each user ID has more than one device associated with it, because this is the kind of thing that Garzilla did. So they took the device ID architecture, and they said, but we want a user ID as well in order to allow people to have more than one camera associated with their account. So they've implemented this thing called a client ID, which is a 6-digit string, obviously predictable, and as we're going to see, really, really stupid implementation. So the way the mobile app behaves is that they send a post to the API with these details, which would be a user ID, Garzilla, password, a complicated password, and that user ID. But yeah, so these user ID and passwords are hard-coded. So these are going to be always the same user IDs and passwords for all Garzilla clients. So the only thing that changes is the user ID. So the posts are encrypted with a AES 256 CBC mode, but the encryption key and the initialization vector are hard-coded in the app, which obviously enabled us to create a small script that emulates the app for any Garzilla client. And this is how a request looks like. And we're actually going to play with it now, because I don't know if you know, some of you know this about me, I love live demos, because what's life without a little adventure? I have a success rate of over 60%, right, in live demos, which is, trust me, it's like insanely well. So I have a camera set up in my house pointing towards the street. So what I'm going to do now is query the Garzilla cloud about the status of my client ID. I'm going to do this from a remote machine in Canada, just so nothing up my sleeves and all that stuff. And hopefully, by the way, do not type passwords. Typing passwords is always bad. Anybody contradict me on that? Do not type passwords. So, BD research, Garzilla, and we're going to use bash history, because why not? So we've created a script in Python that essentially does the same thing as the mobile app, but generically. So you can just change any kind of client ID you want. I've added tail-1 and JQ because this is how it looks, and it looks ugly, and we want it to look pretty. So I told the Garzilla cloud to give me the details of that client ID, 408.311, our client ID, because obviously we wouldn't dare touch another person's client ID. And he gave me back the device ID for a camera. It's called Bugboy with the password admin. And I have a second camera, which is actually not online right now, with the device ID, TinyBug, same password. And first demo worked. Worth mentioning that the users can change the passwords for their cameras. However, since when querying the Godzilla cloud, you get back the password set for the camera, you can set it to a 128 character spaces and hashes and whatever, commas and exclamation marks. The Godzilla cloud is going to tell it anyway. So they're going to, you can do a full account takeover. So there's a number of functions available in that API. One of them is changing all the settings of the account. There's no confirmation sent to the customer. You just change the data and they do it. It's like that. And the old credentials will be invalidated. But we did not want to do this for the demo because we felt that we want to do something cooler. So we built a client that emulates the app. And do not install updates, by the way, when you're doing demos. Words of the wise, trust me. I've been burned a few times. So, essentially what it does, it talks to the Godzilla cloud and tells it to pipe the feed, and we're creating a local pipe. See? Oh, wait. Sorry. No. You don't want to know what I just did, okay? It was the wrong device ID. These are not the droids you're looking for. See? As a not very dear friend of mine said, more better. So we pipe it to VLC. I don't remember all of these things by hand, by heart. So yeah, it's not foolproof, it's kind of buggy, but it works. So yeah, there we go, demo number 1, thank you. Now for my next trick, we found out that we did all that work. We actually wrote a client that connects to that, and we found that there's an easy way because they have an API that's called send invite. That only requires the user ID and the device ID, which we obtained earlier. And it can be used to forge an invitation to allow somebody to view your camera. And very, very funny, the owner has no idea that this is happening. So for my next trick, not just yet. Cool. I'm going to send an invite to my phone. I have Godzilla installed here. Yeah. So, so this is what's going to be displayed on the attacker's phone. Hang on. Somebody invited you to view their webcam. And again, there's absolutely no notification on the owner's interface, dashboard, email, whatever. So somebody can just send a request to the API, invite themselves to view the webcam, and the owner of the webcam will have no idea that that happens. And we accept, and we're going to have the camera disarmed and much better quality. Yeah. So that's with viewing the video feed. But, you know, I promised you guys next-gen IoT botnets. So that means remote shells, right? So popping root on the device. So a few technical information. As I was saying, the cloud platform usually gives a binary to the vendor, and that binary is just dumped on the file system. Their binary is called main.v514.exe. Because, I know, why not? It's a Linux system after all. And the way it's used is that it provides a relay of P2P servers to bypass NAT, essentially, so to allow somebody to view the video feed. And when looking at the way the binary works, we put it in IDA, and we notice the function tcase, the device model require handle, blah, blah, blah. Essentially, a specially crafted buffer sent over the cloud will overflow a few functions in that function. Well, you see string copy 29 and 28. We overflow 28, get into 29, and then we'll get to the return address in the stack frame. And essentially, after that, we have system. So when it's a simple, with a simple overflow, and then it's a simple, this is the entire exploit. The main binary is going to crash, but it's going to stay alive as long as we're connected to it. If you're familiar with the way buffer overflows work, this is how it works in most cases. The binary is going to stay alive as long as we are using it. And we're going to try that now. So we're going to open up another shell on that server, and we're going to try to hack the camera in my house. So, set up a listener, and proper, yes. And there we go. We have a shell in my house. Yeah. ID. I have root on the camera in my house. So the reason I set it up like this is just to show you guys that it's completely fully remote with no direct access. There's no open ports. There's no direct connection or exploiting a service like a telnet or an HTTPD server or whatever, FTP server, DNS server. There's nothing like that. It's just exploiting a binary on the file system that runs that has input sent to it relayed by the cloud. And this is an attack vector that's not that difficult to analyze, actually. It's not that difficult to find, and it's present in, oh my God, so many devices. And if anybody wants to run any commands, this is the kernel version. It's some blah, blah. This is the CPU. And this is APS. And this is my shell. Okay. Onwards. Very quickly through this, we also found the command injection. Essentially, when you send, again, through the cloud, you tell the device that it has an update, and that update is available at one location. It's going to try to download something from the location by using a system command, using tar to unpack it. It's going to use the system tar. So if you pass it something that has a semicolon in it, it's going to end the tar command and then execute your code. Because why not? Okay, as a bonus, a funny story. I was doing this talk at DerbyCon, and then another story about the Godzilla paper is that some guys published about the AWS bucket access. So essentially they had all these vulnerabilities and also an open AWS S3 bucket with all the files and all the recordings and all that stuff. And then some guys published that. We saw it on Reddit. So that kind of forced our hand to publish all our research and our entire paper. Fast forward, we believe that they at least closed the S3 bucket. I presented DerbyCon and I said, bonus AWS bucket access and fixed. And because it's a small world, two guys in the back of the room going like, no, it's not. I'm like, that was you guys? Yeah, and apparently the guys that published on Reddit the thing about the AWS bucket were in the room. So on stage, I just paused, opened, and deleted the fixed part. So it's not fixed. Yeah. So to sum up, all you need is just that initial user ID, which is a 6-digit string, completely predictable, incremented by 1 for each customer. There's about almost 600,000 client IDs at this point, and each one of them has at least one camera. Many of them have 2, 3, 5. So that sums it up to probably millions of devices that are affected by this. And you can get both, pop shells on them, connect back shells, and you can also get unauthenticated access to the video streams. As takeaways, IoT is a huge attack surface, and doing IoT security research is fun and it's easy. And this is more of an enterprise message that says, the guys from Guardzilla actually called me. So I got a call from our OEM team saying, hey Jay, some guy from Guardzilla wants to get in touch with you. Do you want to talk to them? And I'm like, sure. And the guy calls me and says, why didn't you tell us? These are the 6, 7 emails that we sent to all of these email addresses that we could find on both LinkedIn and contact on your website. Nobody replied. Maybe you don't know what PGP is, or maybe you're afraid, I don't know. And then I asked him, so didn't you pen test your product before putting it into the market? And he said, I did. And how did you do it? We hired a company to do it. And you paid them money? I actually honestly asked him that question, because to see that there's a 6-digit client ID incremented by 1, and that all you need to interact with the cloud is that 6-digit client ID incremented by 1, took us 3 minutes. I mean, it took us longer to set up the device than it took us to see this, right? So if you're doing pen testing with a company, make sure that that company is a good company. Also, it's trivial to find RCs in IoT. So I just wanted to close by talking, remember I was saying something about legal, and I wanted to touch on this subject with you guys. So just out of curiosity, how many of you work for a company? Okay, no. I don't want to be scared about the forest of hands. How many of you here are independent researchers? So not working for Big Brother. 1, 2, 3, 4. So the reason I'm asking is we have only a fraction of our research published because of legal reasons. Because some of the research that we're doing, because it's a bit frustrating for us that independent researchers have a bit more freedom into publishing stuff than we do. The thing about MQTT and S3 earlier, in a hypothetical, completely hypothetical scenario, let's say that somebody discovered those vulnerabilities, but the only way to talk about them, the only way to expose them, right, is to say that they've tried it, right? Because you cannot say that that S3 bucket is vulnerable until you've seen that it's vulnerable. You cannot say that that MQTT implementation is bad until you've seen that you can actually register to that root in the tree of the design. So if you're an independent researcher and you want to do research in IoT, we are willing to help you do that, and we are willing to share our research with you and allow you to take the credit for some of the stuff that we did. There's a case in particular where we really want it published for the sake of a lot of people. There's a lot of people affected. We were talking about it yesterday evening, and we cannot publish it. And it's frustrating because we want it fixed more than we want the glory and the fame for that find. So yeah, we are happy to help, and feel free to reach out. Thank you so much.
Another awesome talk. Thank you, Jay, so much. Love the demos, and I think I'm not the only one. We can take 2 questions before going to the next talk. We have one over here, and the mic is coming to you soon. The mic here? No? Okay. You can talk into my mic.
So what is your percentage of successfully let's say, breach IoT devices or for vendors that are not hard coding the credentials? Thank you.
So let me see if I got a question. The best success story in terms of the relationship with the vendor?
No, percentage, like I tested 20 devices.
Okay.
Those
okay.
were not with credentials hard-coded. I successfully breached 2, 3,
Okay,
10%.
So let me answer it like this. We've researched about 60 devices, and we were successful in finding vulnerabilities in 54.
And from those, how many were with hard-coded?
It's just not now. Maybe we're going to be successful later. For example, there's the ring thing, right? Initially, we didn't think about looking at that particular vector of attack, but then, which was like last year when we initially looked at ring, but then somebody came, let's look at that. And we looked at it now. It wasn't default credentials. It wasn't anything hard-coded. But as far as vulnerabilities go, everything is vulnerable, man. Absolutely everything. It's just the vulnerabilities that you haven't found yet. The default credentials, hard-coded, is bad, but I wouldn't phrase it as, how many did we exploit and how many had default. We exploited almost all of them, but not all of them had default credentials. Only a few of them had default credentials, actually, so that's a good thing.
We can rephrase like trivial something.
Well, yeah, but
protection just for the front, let's say. You know the picture with the door that has no fence around.
Let's take this afterwards because there's one more question.
Yes,
and
please.
I'm going to be available.
Thank you so much. We're going to take just one more question.
Hi.
Sorry.
Since you started reporting vulnerabilities in IoT devices, have you noticed any improvement in vendor responses?
No. It's always the same vendors that have decent responses, and it's always the same vendors that have shitty responses. So it's like, if it's Google, it's cool. If it's Amazon, it's cool. Even if it's Xiaomi, it's cool. If it's like a brand that's responsible for something, cool. If it's Edimax, it's decent. Not cool, not, well, how is it, like not great, not terrible? and yeah. So it's about the size of the company.
So more popular vendors respond quicker, or
it's because of you guys. It's because of the journalists. Because they're in the spotlight more, and they don't want.
They feel responsible.
Yes.
Yeah. Thanks.
Cool. Thank you so
Not
much, Jay,
necessarily.
once again.